Am I audible or not? Anyone just reply.
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Okay then. So today I'm not going to take any new topic. I'm just going to discuss last topic that I shared in the Google Classroom. So today we're going to talk about the second phase of the compiler, that is syntax analysis. So we know that we have as the first phase the lexical analyzer, and what it does is it identifies tokens with the help of regular expressions. So lexical analyzer identify tokens with the help of regular expression and pattern rules. That is what we have seen and learned in the first phase of the compiler. So then in the next phase, that is syntax analysis, uh, we have to check the syntax of the input. Okay, so checking of the syntax of any given statement or input cannot be done by this regular expression. So we use context-free grammar for that. Okay, so we use context-free grammar, which is nothing but the superset of our regular grammar. So with this context-free grammar, we identify whether the given input uh, or the sentence has the correct syntax. Okay, so if we see the overall of the syntax analyzer, we know that it's going to take the token stream from the lexical analyzer, and it will give the again output as token stream, or we can say as output as parse tree. Okay, so this syntax analyzer, or we call it as parser. So whenever we have the term like parser, it means the syntax analyzer. So this syntax analyzer or the parser takes the input from our lexical analyzer. So in the form of what? In the form of this token streams. So whatever the token streams we have, uh, so this token stream will be taken by the syntax analyzer as an input. So your with this token stream and with this context-free grammar, it will analyze the syntax of the sentence, whether it is correct syntactically, and if it found any error, then uh, it will report about the error. So your parser analyze the source code, that is our token stream, against the production rule to detect any error in the code. And the output of this phase is nothing but the parse tree. Okay. So so your parse so your parser is going to carry out two main tasks. So your parser or the syntax analyzer is going to do two main tasks. Number one, that is parsing the code, looking for errors. So it's going to parse the code while looking for errors, and once it doesn't have any error, then it will generate a parse tree as the output of the phase. Okay, so we expect the parser to parse the whole code even if some error exists in the program. So here, whenever a parser find any error, it may use any error recovering strategies. So overall, a parser is going to do the parsing of the sentence or the input, looking for errors. So if there is any error, it will uh, tell what the error is, and then it will generate a parse tree. Okay, so for generating this parse tree, we have few things called the first one as derivation. So we are going to have some grammar, then we are going to give some input. So with the given grammar or with the given set of production, we are trying to find whether we can get the input string from this set of production rules. Okay, so 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 what is this derivation? So a derivation is basically a sequence of production rules in order to get the input string. So when we're doing this parsing or syntax analysis, we're going to have some set of production rules or some set of grammars or some set of productions. So we are going to use that grammar whether the given input can be obtained from it or not. If we can obtain from it, it is correct. Else, we're going to return the error. Okay. So all we are trying to do is with the given set of production, we're trying to derive the input string. Okay. So while this parsing, we take two decisions for some sentential form of input. So we decide the non-terminal which is to be replaced. So these are two questions or two decisions to be taken, that deciding which non-terminal has to be replaced, then deciding the production rule by which the non-terminal will be replaced. So the two things is, the first one is deciding which non-terminal is to be replaced, and the second one is which production rule is to be used to replace it. Okay, so we can have two modes of derivation in this case. So the first one is leftmost derivation, and the second one is rightmost derivation. So when we say leftmost derivation, as the name suggests, we are going to start deriving from the left side of the sentence. And when we are talking about rightmost derivation, we are going to start deriving from the right hand side of the production. So as we know, we have two derivation. The first one is leftmost derivation. So here it is. So if the sentential form of the an input is scanned and replaced from left to right, so we scan it from left to right and replace it from left to right, then we call it as leftmost derivation, and we also call it as left sentential form. And as we say for the rightmost, we start scanning and replace the input with production rule from right to left. Okay, so here we replace from right to left, then we call it as rightmost derivation, and when we replace it from left to right, we call it leftmost derivation. So here is an example, so you'll understand it with this. So here we have the production rule. So here in this production rule, these are all grammar, right? So here we have three production rule, that is E derives E plus E derives E star E derives identifier. Okay, this is our set of production. So here, as you know, there are few terms like start symbol, terminals, and non-terminals. So in this set of production, what is the start symbol? So start symbol is nothing but the fast production, left hand side of the fast production. So in this case, all are uh, same. So it's okay to say just E. Okay. So E is the start symbol. So then we have what? we have start symbol, then we have terminals, and we have non-terminals. Right, these are three terms you may be coming crossing through. uh, Excluding the left hand side is called the terminal. So in this case, okay, so in this case, that symbol, so do you see what I'm writing in the screen? Start
Yes, sir.
symbol. Okay, so the start symbol is E. Then we have terminals. Okay, non so non-terminals is whatever that is found at the left hand side of our production. So in this case we have only E. So E is our non-terminals. Then terminals. So terminals is whatever that is found in the right hand side of our production, excluding the left hand side. So if we look from the first one, we have plus, then we have star from the uh, so we have star from the second production, then we have id from the third production. So this is our start symbol, non-terminals and terminals. Then coming to the input string, so here we have the production rule, we have the input string. So what we are trying to check is whether we can derive this given input string using this given production rule. Okay, so we are going to check whether we can obtain this input string using this rules of production. So to get this production, all we are trying to do is we are trying to form the production in this format, that is id plus id star id. So first we take this production line, that is e star e, then we do leftmost derivation, that is we start deriving from left. So instead of the first e, we can use this first production. Okay, so in this second one, okay, just a second. Okay, so in this second line, so we derive the question of which production has to be replaced for this given non-terminal. Okay, so instead of this e, we can use this first production, that is e derives e plus e. So instead of e, we replace it with e plus e, then star e. Then we are going to do leftmost derivation. So we start deriving from the left hand side. So the leftmost symbol should be replaced with the require. So we require id. So by using our third rule of production, we can replace e by id. So it become one step, and in the next step, we we we, we replace the next one in the leftmost form. So this is the leftmost one, and then this is the next leftmost one. So we'll replace this e with id, and then in the next step, we replace the last one, that is last e. with id. So in this way we obtain our required input string of id plus id star id. So in this way we can derive a given input string using this rule of production. So this is how we do the leftmost derivation. So similarly with rightmost derivation, so we start deriving from the right hand side of the production. So here in this first one, we use the first rule of production, that is E plus E. Then we replace or derive our rightmost E with the production, that is E derives E star E. So after this, as we are talking about rightmost derivation, so we start deriving from the rightmost symbol. Okay, so what is the rightmost symbol in this case? So this E. So we derive with E with the production, that is E derives ID. Okay, so E derives ID. So this become a step, and in the next step we derive the next rightmost one. So next rightmost one is this second E that is in the middle. So we derive E with the ID. Okay, and then we have left with the this last E. So it becomes the rightmost derivation for as available. So we replace this E with the our require ID. So it becomes our require input string, that is ID plus ID star ID. So in this way we can derive the input string, either it may be in leftmost derivation or rightmost derivation. Then we have this parse tree, as we know that the syntax analysis or analyzer is going to give the output as the parse tree. So all it is nothing but it's just a pictorial representation of our derivation. So it's a graphical depiction of a derivation. So it's convenient to see how strings are derived from the start symbol. Okay. So we know that a parse tree is nothing but a graphical depiction of our derivation. So it's convenient to see how strings are derived from the start symbol. So the start symbol of the derivative is going to become the root of the parse tree. So all this parse tree is going to do is it's going to just represent the derivation in the graphical way. So here let's just see with this one. So here we have an input string of a plus b star c. So a, b, c, these are nothing but identifiers. So when we are talking about the format of derivation, it must give the final as id plus id star id, as this a, b, and c are nothing but identifiers. So if we see its leftmost derivation, this is our leftmost derivation with the respective rule of production that we just see before. So this is nothing but the leftmost derivation. So if we draw it, or if we represent it with the parse tree, then let's just see what is the first step. First step is E star E. We use the production rule, that is E derives E star E. So E becomes our root. Then this is our E that is in the production side. Then we have star. Then we have E. So this is nothing but E derives E star E. So this is how it's going to represent. Then in the second step we have what? E plus E star E. So in the first step we have this. In the first level we have E derives to E and star E. Then in the second we derive this leftmost. We are talking about leftmost. So this leftmost has been replaced by E plus E. So E plus E. So this is our graphical representation of this second step. So in the third step, we just replace our leftmost leftmost non-terminal with the identifier. So we just replace this E with identifier ID. Then in the fourth step, we replace the second most leftmost. That is again E derives to ID. Then last we replace the lastmost with ID. Okay, so 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 this ID plus ID star ID we can obtain it in this way. Okay, so here we are going to start reading it from this left hand side of the first tree, and it will keep going on like this and till the right hand side of the first tree. So it becomes ID then plus ID then star ID. So here what we can get is all lymph nodes are terminals. All final lymph nodes are terminals, and all interior nodes are non-terminals. And we do in order transversal give the original input string. So in order transversal means this going from left to right in the order, that is from ID plus star then ID. So going from left to right is called as in order transversal. So this is how we are going to represent the first tree of this given derivation. So uh, we can we can depict or we can draw any first tree of any leftmost derivation in this way. Okay. Okay, that's it for today. So if you have any question, just tell me. So there may be question from this lab derivation, right derivation uh, in the midterm exam.
Sir, midterm syllabus is up to today.
Yeah, it's up to today. Tomorrow, I may send you some solve problems, but the topic is whatever that we have discussed till today.
Sir, midterm the pattern of exam like there will be
Like
assignment.
we will have around 20 marks for the probably MCQ. Then 10 marks will have either assignment or will have what short answer type or solve subjective.
Okay. Sir, Bhaiba will be in the intern, right?
Yeah, no Baiba will be there.
Yes. Okay.
And okay, just wait a second. So for exam point of view, you may not need to study this Lex program. Okay, means there won't be any question asking you to write any Lex program, but there may be question on Lex program structure or any theoretical may be there, but there won't be any uh, program question with which asks you to write any Lex program. Okay,
Okay.
then and there will be compulsory question on structure of compiler, so you need to have an overview of all the phases of the compiler. There will be compulsory question on that. Right. Thing other than that, and there's other, it might be included. So if you have any question, anything, you can ask now. So if you don't, I assume everyone is okay. So just roll number one.
Present, sir.
Okay, okay, one plus.
Huh?
Okay, once you have your roll number call, you can leave the class. Roll number
Okay.
one,
Okay.
present.
Present.
Okay, okay. Next two,
Present, sir.
three, then four, five,
Present, sir.
six,